All right, today we are diving into one of nature's most incredible magic tricks, germination. It's that exact moment a life form that's been totally dormant gets its ultimate wake-up call and just springs into action.
But how does that even happen? Seriously, how does a tiny speck that looks completely lifeless, something that can just sit there for years or even centuries, suddenly decide, okay, now's the time to grow? Well, that's the big question we're going to unpack today. And what's wild is that this process has a total Jekyll and Hyde personality. On one hand, germination is this amazing engine for new life. I mean, it's the foundation of our entire food supply, our forests, everything. But on the flip side, it's the trigger for some of the toughest, most dangerous pathogens out there. Two totally different outcomes from the exact same survival strategy.
Okay, so let's get into it. Before any of that action can happen, both seeds and spores have to wait. They enter this state called dormancy, which is basically nature's ultimate pause button.
So what is dormancy? You can think of it like suspended animation. All the internal machinery just grinds to a halt. And we're not talking about a short nap here. Get this. Back in 2005, scientists managed to germinate a 2,000-year-old date palm seed they found in an archaeological dig. It wasn't dead, it was just waiting. Patiently waiting for the perfect moment to wake up. So let's meet our first character in this story, the plant seed. The best way to think about it is as a perfect little time capsule. Tucked inside that hard shell, you've got a tiny plant embryo and its own prepackaged lunchbox, stuffed with all the energy and nutrients it needs to make its grand entrance into the world. And then we have our second character, the bacterial spore. Now, this isn't a time capsule so much as it is an armored survival pod. I mean, spores are the ultimate survivalists. They're built to withstand things that would obliterate just about anything else. We're talking boiling water, powerful disinfectants, even the vacuum of space. Their whole mission is just to endure, waiting for that one chance to reactivate. So, what kicks this whole process off? What's the signal that flips the switch from off to on? What tells a seed or a spore that, hey, the time is finally right? Well, for a plant seed, that wake-up call comes directly from its environment. First and foremost, it needs water. Water gets everything going again, rehydrating its insides. Then it's sensing the temperature, which is how it knows if it's spring or if it's still the dead of winter. And yeah, some seeds are super picky. They're even waiting for the perfect amount of light or darkness to tell them they're close enough to the surface to grow. Now, here's where it gets really cool. Inside that seed, there's basically a chemical battle going on. You've got one hormone called abscisic acid, or ABA, that's slamming on the brakes, keeping the seed dormant. But when the conditions are just right, another hormone, gibberellin, or GA, hits the gas pedal. And germination only happens when that gas pedal finally overpowers the brake. It's a real tug of war. But spores? They are listening for a completely different signal. They couldn't care less about rain or sunshine. They are waiting for one thing: food. The presence of specific nutrients, like amino acids or sugars, is the signal that tells a spore it's landed somewhere hospitable. Like in a wound or maybe some improperly canned food, a place where it can really thrive. Okay, so the trigger has been pulled. Let's look at what happens in that very next moment. Because this isn't some slow, sleepy awakening. It's a fast, perfectly choreographed explosion of life. For a seed, it all begins with imbibition, which is a fancy way of saying it just starts chugging water and swells up, sometimes cracking its own shell. That water activates enzymes that start breaking down that packed lunch, releasing a burst of energy. Next, the radicle, the very first little root, pokes out to anchor itself. And finally, the plumule, the first shoot, starts pushing its way up, searching for sunlight. A spore's awakening is just as dramatic, but it happens ridiculously fast. We're talking minutes. It dumps a huge amount of a chemical called dipicolinic acid, which lets water rush back in. Then, it literally sheds its tough protective armor and transforms from that dormant pod right back into an active and, potentially dangerous bacterium. So, the big question, why does any of this matter? I know it might all seem like a pretty tiny microscopic process, but its impact on our world is, well, it's absolutely gigantic. Let's take a look. Honestly, it's almost impossible to overstate how important seed germination is. It is the starting line for nearly all of our food, the wheat, rice, and corn that feed billions of people. It's how our forests come back to life after a fire, how biodiversity keeps going, and it's how new plants grow to pull carbon dioxide right out of our atmosphere. But that's only half the story.
while all those seeds are busy building entire ecosystems. The germination of a lot of bacterial spores has a much darker purpose.
And as you can see here, spore germination is the critical first step for some truly devastating diseases. Whether we're talking about Clostridium perfringens causing gas gangrene, or Clostridium botulinum, which leads to botulism, or even C. diff, causing really serious hospital infections, the story is exactly the same. A dormant spore wakes up, and disease begins.
So we're left with this really powerful idea. Germination is this universal strategy for survival. It's a tiny biological package just waiting, holding all this incredible potential inside. And the final question is always the same. When it finally gets that wake-up call, is it going to unleash the beginning of a forest or the beginning of a fever? The answer, it turns out, all depends on whether it's a seed or a spore.